Camilla, what is one transformation? Just one I needed. That's all right. Left 3. Good. And you already gave us the second one. 2. Down 2. Okay. Stefan, what's another one? Good. Reflection. Over X. Axis. Good. And then one more, Liam. Okay. Tate. Excellent. Good. The vertical compression. By 1/2. Okay, the 1/2 in front represents the vertical compression. The negative is the reflection. Okay, how many of you did get number 1 correct? Good. Okay. Yep. If you take the absolute value of A, okay, then if that's between 0 and 1, it's a compression. If it's larger than 1, it's a stretch. Okay? All right, for number 2, see, Porter, what's the vertex? Careful. For this function right here, the new one. Which direction are you moving in? Start with that. Okay. Emily. 0, -3, because what direction are we moving? Down 3. Okay. When it is outside, parentheses, okay, not attached to the X, then it's up or down. So we have 0, -3. The shape is still the same. Okay. And we have our quadratic. Okay. All right. Robert, for B, what's our vertex? 1, 4. Excellent. 1, 1, 4. What is our vertex, Emily Taylor? I mean vertex. What directions are we moving in? Sorry. Up how many? Okay. All right, so that's one transformation. Up 4. And then, Mia, what's another? To the right 1. And only for absolute value, you have your slope, which is the A value, right? Which is 1. So we should have this V shape. Okay. How many of you did get B correct? Good. Okay. Now for C, we have our square root. Anthony, what's our starting point? Careful. Remember, it's the opposite of what you see because it's inside and next to the X. -4. So you would take whatever's inside, set it equal to 0, and show that you have -4. Okay? So your starting point is -4, 0. Okay? What transformation is happening, Ava? Reflection because it's negative. And then Zach, what else is happening? Left 4, good. Okay. Now, some people have asked, how do we know what this graph, like what X values I should plug in? Okay. Well, we could always start with the one right next door, which is -3. -3 plus 4 is what? -3 plus 4 is what? Careful. -3 plus 4. 1. What's the square root of 1? times negative 1, negative 1. Okay, you could also choose an x value that's going to make that square root a perfect square. So if I chose negative 2 plus 4, I get 2. That's going to be a decimal. Not nice. So if I choose negative 1, I get 3. That's going to be a decimal. Not nice. So if I choose 0, 0 plus 4 is 4. The square root of 4 is 2 times negative is negative 2 to find your graph. Okay? All right. Any questions on those? Yep, yeah.
So just to find the x, you use like different x values to plug them into the function already.
Correct. Yep. And for square roots, you only want what's going to make this a perfect square. Okay? And your starting point is the last x value you could use. Everything to the right of it. Okay? All right. In 3, given the vertex form of a quadratic, for what values of a does a reflection across the x-axis take place? Luce. Good. When a is less than 0, means is a negative. Okay. What are the coordinates of its vertex? So if I give you vertex form, A, H, or K, what is the vertex using those variables? Yeah, Emily. HK is how you find the vertex. Okay. And looking at this new equation, let's see, Rory, what's our vertex? Perfect. Good. Excellent. Okay. Any questions about those? Okay. I looked through as I was checking your homework. There was a lot of corrections, which is awesome. Okay. And we didn't erase, we just actually made the corrections. A lot came down to the x and y intercepts, I think. Okay. So one thing to keep in mind, when you are finding your x-intercepts, you set y equal to 0 and solve. Okay. When you are finding your y-intercepts, set x equal to 0. All right. So if we look at 2c, okay, if we're given this function, okay, some cases you're not able to see the x and y intercepts on the graph, but you could find them algebraically if there are any. So to find x-intercepts, we're setting y equal to 0. Okay, what is our first step in solving? Yeah. Good. Add 4. And then what do we do? Yeah, Tyler. Square both sides. And last but not least, Emily, subtract 9. So our x-intercept for 2c was 7, 0. Okay. Now to find the y-intercept, using the same function, substitute 0 in for x. Okay. What is the square root of 9? Yep. 3. And 3 minus 4 gives you negative 1. So the y-intercept was 0, negative 1. Okay. So this is how you would find your x and y intercepts. Doesn't matter what equation it is. The only one that changes is if we have absolute value. Okay. Absolute value with x-intercepts, you would isolate the absolute value. So for example, if I had if I had this, okay, and I want to find my x-intercepts, okay, you first have to set it equal to 0. However, this is important information to have down, okay? When you have x-intercepts for absolute value, you're going to have two. You isolate the absolute value, and you set x plus 3 equals 2, and then x plus 3 equals negative 2. The reason is, the definition of absolute value is the distance from 0, okay? So when you're finding your x-intercepts for absolute value, you have to have two equations, okay? One positive and one negative, due to the fact it's the same distance from 0, okay? Any questions? There's a few of you writing this down, so I'll give you a minute. Okay, we are now working backwards. Okay, determine the parent function based on the shape. Right. Think about where the vertex starting point or point of inflection, which all use what variables? Vertex, starting point, and point of inflection all use what? Yeah? H and K. Okay, so determine your parent function. That's either quadratic, square root, cubic, or absolute value. Okay, from this point, determine if the graph is reflected. If so, make A negative. Okay, from that same point, determine the slope to the next point. There's a certain way to solve these. The slope will only really work for absolute value. Okay, we will determine an A value a little bit later. The majority of these, you're not going to really have to find the stretch or compress. Okay, except for absolute value. All right. So, for number 1, what is the parent function? Finn, what would the parent function be for number 1? It would be cubic. So we know the parent function is x cubed. Okay? Because it's very similar to a line. However, we have a little dip there. So if it's x cubed, what am I looking for? Vertex, starting point, or point of inflection? Tyler. Would this have a vertex? Vertex is the lowest or highest point. So this one would have what? Emily? Point of inflection, which is our HK, which is where? Okay. 4, 0. Okay. Is this reflected at all? No. So the A value is not negative. So how would I write this equation? Yeah. Go ahead. Awesome. Good. Perfect. Okay. So you have f of x equals x minus 4 cubed. Cubed is the parent function. Since we only move to the right, it's x minus 4. Okay? So number 2, what is our parent function? Ava? Absolute value. So would this one have starting point, point of inflection, or vertex? Vertex. And what is our vertex? Yep. Good. Negative 6, 2. So how would I write that in an equation? Let's hear from some others. Yep, Liam. Would it be square root or?
No, it's absolute.
So x plus 6 and then plus 2. Awesome. Okay. So the absolute value of x plus 6 inside parentheses, inside the brackets, plus 2. Good. All right. Now number 3. What is our parent function? Anna? It is a quadratic. Okay. So it's our quadratic. What is our vertex? Yeah. 0, 0. But what else is going on with this graph? Emily? It's reflected. So what would be my equation? Yep. Go ahead. Good. That's it. Awesome. The only thing that's different is we tack on a negative because it's reflected. Okay. For number 4, what is our parent function? Sorry? Square root. Good. So the square root of x uses starting point. What is our starting point? Which is also HK. What is our starting point? Porter? 0, 2. Good. Is our starting point. So how would I write that as an equation? Luce? Good. Awesome. Okay. I want you guys to try number 5 on your own. Okay, try number 5. Okay. What is our parent function, Kennedy? It's a quadratic. Awesome. Okay. Camilla, what is our vertex? Good. For negative 2. All right. Who has our equation? Anthony, go ahead. Perfect. Nice job. How many of you guys got that? Great. Good job, you guys. Okay. So nice job with coming up with the equations. Okay. Now, if we turn the page, these transformations can happen with any random function. So if you look at the bottom of the page, these are all random functions. Okay, it's not a quadratic, not an absolute value, not square root, not a cubic. It's just a random function. So, however, A, H, and K still mean the same thing. It's just written differently. It's written A and then f of x minus some number or x plus some number and then plus k. So this is what it looks like here. However, the transformations are still the same. So if I see f of x plus 2, what does that mean in terms of transformations? So if I had x plus 2 squared, what does that mean? Yeah. Good. Left 2. So the random function is just moving to the left 2. How about B? Everett. Good. Right 3. All right. And in C, what else is happening? Luce? Good. Left 1 and then up 2. So nothing has changed, just their like random functions. That's it. Like you see here. Okay? So if we look at A, what is happening? F of x minus 1. What does that mean? Emily? Moving down 1. So all of these functions, all of these points are moving down 1. One key with these, connect as you go so you don't lose your place. Okay? So -7, 0 is now -7, -1. -3, 5 will now become what? Yeah. -3, 4. Good. I'm just going to connect. 2, 5 is now 2, 4. 6, 8. 6, 7. Okay. Okay. So in B, what types of transformations are happening? Finn? Good. So go ahead, you guys, and move that function. Is happening in C. Yeah. Good. It's reflected. Okay. Since it's reflected over the x, if I have a point here, and we're going to jot down some points so you could see. I know this graph isn't the greatest. Okay. So if I have -5, -1, if it's reflected, what would my new point be? If it's reflected, what would my new point be? If I'm -5, -1, Emily? Good. -5, 1. If I'm -2, 2, what would my new point be? Finn? -2, -2. I'm just going to connect as we go. All right. -1, -1 would now become what? If -1, 1. Good. And 2, -1 would become what? Tate. Good. Okay. 4, 3 would now become what? Tyler? Or -3. Okay. And there's one more here. 5, 2 would become what? Emily? So what did you do to get those new points then? What did we have to do? Yeah, Rory. Switch the y values by doing what? What operation? Add, subtract, multiply, divide. Yep. Multiply by -1. And the reason I'm specifying that is because if you are given a point, just one random point or multiple points, and had to transform them without a graph, you have to know what operation is happening. Okay? So, for a graph of f of x with point 1, -7, determine the point's new location if the graph is transformed using f of x minus 4 plus x minus 1 plus 4. So what transformations are happening? What is 1? Christopher, what is 1? Going to the right. 1. What's another one? Robert? Up 4. So if it's moving to the right, what's changing, x or y? Luce? X. So what are you doing? What operation? If your x is changing and you're moving to the right, what are you doing? Yep. Addition. So you would add 1 to x. So my new x value is what? 2. Okay. Now if I'm moving up 4, what operation am I doing or using? Yeah. Yep. So what's my new y value? Emily? -3. So that would be your new point. Okay? All right. And the last thing is working with dilations. Okay? Which is what we've actually done with our normal functions, just not with random functions. Okay? So again, reminders, stretch, compress. We're multiplying the y values by this. Okay? So in A, what is happening? What do we have to do? What types of transformations are happening? Yep. But, okay, this is a vertical stretch. By 2. Okay? So that means, what are we doing? What's changing, x or y?
Lucy?
Y. So you're multiplying your current y values by 2. Okay? So if I have -3, 4, what would be my new point? Lucy? -3, 8. Should be up here somewhere. Okay? Then I have 1, -1. What would be my new point? Right? 1, -2. Connect as I go. Okay. How about 2, 3? What would be my new point? Ava? 2, 6. Good. Okay. And then 4, 3 would become what? Emily? Good. Okay. That's a vertical stretch. By multiplying your y values by 2. Okay. And in B, what's happening? Yeah. It's a reflection. Anything else? Yep. Good. Vertical compression. By 1/2. So if I had -3, 4, which is my point, -3, 4, what would be my new point? Lucy? -3, you were right the first time. -2. -3, -2, because you're multiplying 4 by -1/2 to get -2. Okay? How about 1, -1? Everett? Good. 1 and 1/2. 1 and 1/2. It's here. Okay? And then we have 2, 3. What would 2, 3 become? Yep. No, it's okay. 1.5 is easy. Easy to see. Good job. And then would 4 be the same? For -1.5 as well. So if you notice the difference, actually seeing it firsthand, the stretch, everything gets longer, okay? Compression, it gets shorter, okay? Questions? Yep. Correct. Yep. Okay. And the last is just tying it all together. When there's multiple transformations happening, the best thing, the most important piece is your stretch, shrink, and reflection have to happen first. Okay? Your multiplication has to happen first before up or down. Okay? Yes. So here, no, this doesn't have the vertex at all, this graph. Okay? So what's happening, what are the transformations happening? Let's start there first. Okay? Hannah, give me one. Vertical stretch by 2. So what type of operation do you have to do, and what values are they affecting? What do we have to do? Lucy? What values? X or Y? Yep. Multiply Y by 2. That's actually the first thing that needs to happen. Okay? Then what other transformation is happening? Everett? Right 4. So what do you have to do there? Add, subtract, multiply, divide. If we're moving to the right, we're adding. Okay? Add 4 to X. And then what is the last transformation happening? Mia? Down 1. So you're subtracting 1 from Y. So since there's 2 transformations happening to Y, multiplication, because of PEMDAS, has to happen first. Okay, that has to happen first. All right. So if you want to use some key points to help you transform this graph, you could use those 4. Okay, which is -5, 1, -3, -1, 3, -1, and then 5, 1. Okay, so I'll just do the first point with you, and then you guys are going to try it. Okay, -5, 1. Okay, I have to multiply the Y value by 2. So 1 times 2 is what? 2. -5, 1. So the vertical stretch, okay, then I have to move to the right. So -5 plus 4 is what? -1. Okay, so that's right 4. So -1 stays the same. Then I have to subtract 1 from Y. So our new point for this transformed function is -1, 1. Okay. How about -3, -1? What would it be? Yeah, Anthony. Careful. Careful, careful. Negative, okay. So if we do the stretch, right? Okay. -1 times 2 gives you the -2, right? But we still have to move it to the right. So -3 plus 4 is what? 1, okay? Then I have to take -2 and subtract 1 from it. And what do I get? -2 minus 1 is what? -3. So my new point is 1, -3. How many of you did get that for that one? Good. Okay, so 3 -1 would now be what? The y values are already done for you. Tyler? 7 -3. And the last one is off the graph, obviously. But it would be 9, 1. Okay, 9, 1 would be the last one. All right? So I want you to try the next one on your own. Okay? Next one on your own. Describe what transformations are happening. Okay? Then move those points. Yes. Yep. Okay? Describe the transformations are happening. I'll put the points on so you guys could see it. I know the picture is not really clear. Okay. We're going to go through what transformations are happening first. Okay? Tate, what is one transformation? Good. Okay, reflection over x-axis. Porter, what's another? Yep, left 2. And then Robert, what's another one? Up 3. Okay, so if I was to look at points, okay, -5, -1 became what? I know it's off the graph, but what would it become? Yeah, Kennedy. Good. It would become -7, 4. Awesome. -2, 2 would become what? Mia?
But if you have a reflection over the x-axis, are you dividing by 2?
You're multiplying by -1.
Oh.
Okay. -2, 2 would become what? Porter? Yep. -4, 1. Good. -1, 1. -1, -1 will be what? Yeah. Good. 2 -1 will become what? If 0, 4. The last one. 4, 3 is what? Yep. Huh? Two is right. 2 is right. Yep, Liam. Good. Okay. So how to get those? For example, 4, 3. I move to the left 2. I'm now at 2. If I reflect it, then 2, 3 now becomes 2, negative 3. But I have to move up 3. 1, 2, 3. So I end up there. Okay? Any questions? Yep. All you're doing is multiplying your y values by negative 1. The reflection is the negative in front. Okay? The negative in front means reflection, so you're multiplying your y values by negative 1. Okay? All right. Get into some practice.